Right, so the fourth example. A particle is projected horizontally with a velocity of 39.2 meters per second. Find the horizontal and vertical components of the velocity of the particle 3 seconds after projection. Find also the speed and direction of motion of the particle at this time. So our setup, from somewhere up here, we've got a particle, it's been projected horizontally with a velocity of 39.2, so ux equals 39.2. It's falling, and then 3 seconds later it reaches this point. So here t equals 3, and now we're interested in its speed, we're interested in its velocity, and that is also divided into vertical and horizontal components. So it's going to have a horizontal component of velocity, which, as we mentioned earlier, because there's no acceleration in the horizontal direction, the Vx and the Ux always remain the same. So I know that that is 39.2. What I don't know is what the horizontal component of that is going to be. So I don't know Vy. So this time I'm not given any information regarding its position after 3 seconds, and I'm not being asked to find it. So this is one of the ones where I'm not going to be using s equals ut plus half at squared. I'm looking for one that links velocity, initial velocity, acceleration and time, which is the first Suvat equation that we discover, which is v equals u plus at. So if I'm going to be using v equals u plus at in vector form, I've got Vx, which I know is 39.2. Vy, I don't know, but it's moving in the negative direction, so it's going to be minus, I don't know why I put a question mark there, minus Vy. I should have put there, sorry. So 39.2 minus Vy. U is going to be 39.2 in the horizontal and 0 in the vertical, plus Ax is 0, Ay is 9.8, and T is 3. So you can see here that in the horizontal motion, I don't need to, there's no unknowns there. 39.2 is independent of time, the final velocity or the velocity at any instant. But here in the vertical, I've got minus Vy equals minus 9.8 times 3. So Vy is going to be 29.4, which to two significant figures is 29 meters per second. So find the horizontal and vertical components of velocity of the particle. Done. Vx is 39.2, Vy is 29. Find also the speed and the direction of motion of the particle at this time. So what we have now is that we know that this particle is traveling with a horizontal component of 39.2, a vertical component of 29.4 in that direction, and the speed is basically the modulus of that. It's Pythagor again. So V is going to equal the square root of 29.4 squared plus 39.2 squared. That flies back. I'll get a rolled up newspaper now when I finish this example. So 29.4 squared plus 39.2 squared square rooted is 49 meters per second. And if we want to find the direction of motion, well, we'd measure that relative to the horizontal, so that would be theta. Theta, that vertical line there, can be taken over there, giving us the right angle triangle. So using right angle trig, theta is going to be opposite over adjacent, inverse tan of 29.4 over 39.2. Now it's important, particularly in year 13, where so much of the maths you use, you work in radians, it's important to make sure that you check that your calculator has got a D there for degrees, because most of the time, not all the time, but most of the time in mechanics, we use degrees. So mine's in degrees, so shift tan fraction button 29.4 over 39.2. So that equals 36.86 degrees, which rounds to two significant figures to 37 degrees. So it's travelling at an angle of 37 degrees below the horizontal at a speed of 49 meters per second. So I'm going to turn it off now and go and mangle a fly.